Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway systems specialist working in this industry for 24 years and counting. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. Hello and welcome to Railway Insights, your go to podcast for an in depth look at the world of railway transportation systems. I'm thrilled to introduce today's guest, Mr. Daniele Diana, a distinguished technical director with over 20 years of expertise in RAMS, reliability, availability, maintainability, and safety at WSP United Kingdom. As a chartered electrical engineer, Mr. Daniela is an authority on European and international railway RAMS and functional safety standards, covering a wide spectrum of CENILEC and IEC. His extensive knowledge extends to reliability engineering, safety engineering, and more. Throughout his career, Mr. Diana has played a crucial role in supporting clients through the RAMS process, managing small and large teams, manage suppliers' documentation integration, and serving as an independent assessor. Join us as he shares insights into RAMS standards, safety requirements, and the intricate world of railway transportation. This promises to be a captivating discussion with an industry luminary who has actively shaped RAMS standards for over a decade. Hi, Daniela.
Hi, Rahiman.
Welcome to Railway Transportation Systems podcast. So let's start with our first question. Can you provide an overview of the RAMS, reliability, availability, maintainability, and safety in the context of railway transportation systems?
Thank you. RAMS is an essential element for the railway system. It supports law and regulation, is essential for social benefit in the sense that is helping safety, is also supporting innovation and introduction of the new innovation through its element, is fundamental to reduce the cost and improve safety, and also used in the contract to evaluate the railway system performance and link most often to penalties. I want to explain about overview. In the railway system, we have a set of harmonized standards that are serving the three pillars of rail. So signaling, rolling stock, and fixed installation. Those standards are supporting the law and regulation in different countries and are helping to regulate the subject matter. Why we do RAMS in rail systems mainly? It's just because it's the right thing to do, and that is what I typically say. That is very, very useful.
Thank you, Daniela. What a great overview. It's really, you have summarized RAMS in less than 2 minutes, I guess. I'll move to my next question. How do international standards such as EN 50126, EN 50128, EN 50129, and other related standards contribute to ensuring the reliability and safety of railway systems, and what challenges do they address?
As a standard reviewer, very deeply involved in the standardization and just, and in the problems related to the standards or the challenges that those are facing. Mainly, the standards are made to harmonize and to create a more interoperable railway system. They ensure quality and reduce, one if used properly, the risk. What kind of risk? The project risk and also the commercial risk, in the sense that they provide a set of rules and guidance that represent the consolidated state of the art. Basically, we have a lot of companies that are providing experts in the subject matter that have the task to write standards and to provide the experience, the expertise in writing and sorting the problems from the RAMS perspective. This will facilitate, on one end, a common language, common requirements, and will also go and provide a sort of common ground for everyone to deal with. This is a very good thing for competitiveness and for sorting the industry need. Also, the standard address the innovation as I was anticipating before, and for example, the new trends like AI. So this is something that will be introduced. The most challenging part, as a lot of other things I would say, is to have everyone on the same page, and because every industry, every company, every one of us has different needs, and also those needs, in order to be addressed, needs to be discussed. And usually, I would say the standards are not perfect, just a very good compromise, I would say.
What a great way to express standards as compromiser, which is new, I have heard. Thank you, Daniele, for bringing this to this forum. You have answered a complex question in a very comprehensive way. Thanks for bringing this onto this forum. I'll go to my next question. Is something, it's like a follow-up. As you are a seasoned professional, could you share specific instances where RAMS processes have played a pivotal role in enhancing the performance and safety of railway operations?
Thank you for the question. I think RAMS is always pivotal to railway operation, in the sense that if we do RAMS, there is a reason. It's not only because, in most of the country, so law and regulation enforce a few of the elements of RAM, or they have providing requirements. The reason behind it, just we are willing, so the industry wants to do things better. Now, the experience, of course, after so many years, I have seen a lot of practical cases and practical application on where things went well or not particularly well and needed to be fixed, and where RAMS was really an essential element to fix that. So let's go in order. For example, what is coming up in my mind. Start with safety first. There have been, of course, I will not make reference to specific project or names of persons. That is something I will not do. Just I can provide the situation where redundancy in place for safety-related functions. For example, activation of emergency brakes, and those functions were done by software that was, I would say, not explicitly written according to the requirements, and there were examples where the train was or without emergency brakes. And that was where, the structural analysis of RAMS, so with the root cause analysis, was to sort out the situation, identify where the problem was, and fix it. And other interesting things about safety, for example, I've always been passionate about, the safety of railway tunnel, and all the changes that, as an electrical engineer, to suggest to the system engineers and to designers to fix or just to fulfill the requirements of the safety in railway tunnel, meaning the number of minutes that the train needs to still run with a fire on board. That's super interesting and very challenging, and also with all the simulations. Of course, there were simulation. We were not going to try a train with a fire on board if our simulation were working, but that was really important to fulfill the requirements. But just not to stop a train when there was a fire on board that was of course damaging the systems that were on board of a train. Of course, my examples are mainly from rolling stock, one of my first passion, I will say, and where I have most of my experience together with signaling on board. In terms of reliability and availability, what happened, for example, there was a train with a nice control system. where the function were super robust. The fact that nobody was so taught to verify the fact that the function and the redundant function were on the same power supply, that was a little problem when the train got stuck. And so that has been fixed, remapping all the power sources. And that is clearly RAM engineer job with the application of few methodologies that they are called, for example, FMICAs, and just where you analyze the single point of failures. Example, maintainability is just the ability of a system being maintained, and as such, also to be maintained, the system needs to also be accessible. A lot of engineers before the 3D CADs were not evaluating what is in front of the system they are putting in place, and so it happened sometimes that the system were not necessarily accessible. So we had to run study of accessibility with the use of 3D CADs, for example, and also inspecting the real system and see how many panels were in front of our system and how to correctly evaluate the time to access and repair the system in case of replacement, because that is also affecting the reliability and availability of the system. So the availability mainly of the system.
Great examples.
As well.
Really great examples. You covered both signaling, rolling stock, and maintainability, including safety. So one simple follow-up question, I won't take much time. Within this, you explained the RAMS involvement. In a project, where do you guys sit in? After design or before design, right from the front of the V-cycle or at the end of the V-cycle?
Well, I will say RAM is everywhere around you. So as the standard says, we as RAMS engineers or RAM specialists, we see on all phases of the life cycle. We are always next. So we start being involved at concept phase, and there is also something to do for us at the disposal phase of the system. So if you think about train, you start at the very beginning, so in the bid phase, when you start providing your support to the bid, and I was been a RAMS bid manager and report for a few projects, and then up to the end. So, and all the RAMS elements will be involved in all the phases of the life cycle.
Great answer, Daniele. I'll move to the next question. As you said, you are everywhere in the entire V cycle. So with the management of suppliers at the beginning, how do you approach the management of supplier RAMS documentation to ensure a fully integrated, safe and reliable railway system?
Thank you. That's a very nice and difficult question at the same time. Integration is one of the big challenges in all the system, in particular the railway systems. The reason is because it's typically not really taken into account. Basically, what I'm saying is, when we design a system trying to make it work. Sometimes it slips our mind the fact that this system needs to be integrated into an IGA system and need to work in an integrated way. So that's why the standard, I would say, is of fundamental importance, because it's guiding and is providing you the right steps to get there, and is providing the experience of many engineers that are telling us that we should think about integration at the very beginning of the project, not when it's too late, because then the systems that need to be integrated are not speaking each other. So this is very, very important subject that needs to start and needs to be debated since the early stage. So the system must be designed, be integrated. It's not just, we built what we like, that is fulfilling the requirements, and then say, oh, by the way, we need to integrate it. And now what? So, and that is proceeding. So that means proceed in a very structural way. So you start from the early stage with a nice system definition, defining all the interfaces and boundaries. And then when you have identified the boundaries, also the scope split and the responsibility split, meaning that you start identifying also the supplier and where the requirements that are going to the supplier and also the interface requirements are going to. Okay. Then once we have provided the specification of supplier, we need to follow up the supplier and closely look at the supplier documentation in particular are being responsible of integrating the RAMS documentation at integration level for the train, but then the train was mostly integrated in another railway system. So basically, while on one end I was managing the supplier, in this case for rolling stock, and integrating and demonstrating the rolling stock requirement through the support of the supplier documentation. At the same time, so it's important to keep an eye on the next level as well, and what are the requirements we might need to fulfill, and also what is that constraints we have and how we are going to interface with the IGA system. So that is basically my answer to the question how to manage. It's a fundamental, not only because of the supplier and you are managing different entities, but also because it's a very difficult element of a full design, basically.
I do agree. Wow, what a complex system. And the way you explained it is brilliant, especially when you said the system to be integrated and not you design it and then now it's the time to integrate. I really appreciate the wisdom you're bringing into this forum, Daniele. It's a really great answer. I really loved it. I'll move to your next role.
Thank you.
In your next role as an independent assessor, what are the key responsibilities and challenges you face evaluating and judging compliance with the RAMS standards and regulations?
Thank you for the question. I've been working as a lead assessor and lead assessment body, which are two ways of doing the assessment. One for the Senelec standard, basically, and EN process, and the other one is looking for the common safety method and risk evaluation and assessment. So one is regulated by the standard, the other is regulated by the law. All in all, they need to be independent assessor. So when the things I will say here are typically are valid for both roles. The duty of an assessor are clearly stated in the regulation and in the standards. An assessor needs to enter, and preferably at the very beginning of the project. That is what everyone is suggesting, because the assessor needs to get the feel and understanding the system and the operational context. And the assessor needs to meet people and understand if they are knowledgeable enough. So one of the duty of the assessor is to assess the competency of the people working on the project. And if they are independent enough, for example, one of the requirements that typically is overlooked is the independence of the validator, independence of the verifier that cannot be involved in the design. And the new standards that are evolving, introducing even more requirements to the independence, because the experience is teaching us that, there are ways into the standard, and it's better to keep a few of the roles within a project to be independent so that they can analyze and identify problems and give a very well structured approach and reassure that the system is going to be what the customer wanted in the first place. Basically, the assessor is evaluating the compliance to the process, the activities, and the fitness for purpose. It's evaluating the change management system, the organization structure, as I said, the seal allocation process, and how the company is doing auditing. All this stuff is recorded in a document that is called Safety Assessment Report. So basically, from the external perspective, the assessor might be seen as doing very little because he's producing only two documents. One is a plan and one is a report. But I can assure you that it's very, very difficult, not only because, you need to judge the work of other people, but also because you need to be independent yourself, because it's called independent assessor for a reason. And independent in what sense? In the sense that, you don't need to be involved by any means in the design or provide design solutions. So I met and I've been discussing with assessors that they tend to give their own imprinting to the project, which is not right. So an independent assessor is coming, is not providing a solution, is checking if you are compliant with the standards or regulation requirements and giving the judgment if you are going in the right direction. How? Doing spot checks. Is not a validator, is an assessor.
Yeah.
So that is, the main difference and challenge I see in very short time. We can speak for hours.
I do agree. But it's a complex role. It's not about producing two documents, but this role is very important to lead the project and to make sure the project is going in the right direction. I just want to elaborate one more thing on the role of safety integrity and safety integrity levels in the railway industry, and how are they allocated and demonstrated.
Okay, well, it seems we are moving from topic to an even hotter one.
Yeah.
So, safety integrity and safety integrity level is one of the most debated topic, and one I've been very specialized, and also one we have been writing a lot within the standardization working groups. Let's start a bit with what safety integrity is, and from the correct definition. So, safety integrity is the ability of a safety-related function to perform under the stated condition and the given environment. So, meaning safety integrity is for functions. What function? Safety-related functions. So, not for system unless those systems are performing safety-related function. And that is the first catch, because the SIL label is attached to the system. SIL is a level that is allocated to the safety integrity, and it went originally from 1 to 4, and there was a 0, and that has been replaced with basic integrity. At 0, there's been always a big discussion at 0, meaning not safety or safety. Now, we do have a basic integrity that is replacing the concept of SIL 0, and we have SIL 1 to 4 being the most stringent requirements for safety integrity. Basic integrity is there and can be used, I repeat, can be used for not safety-related function if someone wants to. There are a few standards, so for example, the 50657 that is enforcing for safety and not safety-related functions to have basic integrity as a minimum, but that is, a very specific rolling stock requirement. So the discussions and come since the origin, the 61508 standard, that is, the most wide and well-known functional safety standard. And the important to know is just the SIL was born to cover in a more structural way the fact that we have electronic system in the railway. Let's start only speaking about rail that might and might not have software, and we need to find a way to make them more resilient, more robust, not only looking at the quantitative figures, so say hazard rate, failure rate. So the standardization working group at that time came up with a list of measures and architectures that make the system more robust and fail-safe. For example, if fail-safe is one of those requirements that are needed if you speak about most of the signaling systems, for example. So the system is looking after the systematic and random integrity. So basically looking after the systematic failure element and the random failure element. So those that are taking into account the process and those that are taking that the system may randomly fail. So how the SIL is apportioned? Well, our standard is mainly foreseeing the main route as being the quantitative route. Okay, and this is done through a functional breakdown of our safety functions, basically, and those are linked to hazards. So the top level is allocated with a tolerable hazard rate. Then this tolerable hazard rate, through a fault tree analysis, typically is broken down to other THR, and there is one level, one and one only, that is the implementation level. That is, the level where the safety integrity must be applied is where the THR changed name into the TFFR, and that's where the SIL is allocated. So the SIL is not allocated at super top level. It's not allocated to multiple things. So, for example, I've been seeing misuses in allocating SIL to the all-door systems, so the door of a train, that is impossible to apply because, the target might, and the quantitative target might change, being that the train made of 40 doors or 20 doors. So something that is not the integrity of the functions performed by the door, basically, needs to be always the same and achievable. So the standard is also taking care about this misuse. So apart from this methodology, which I'm very passionate about, probably you've seen that, there are other methodologies allowed, in particularly the risk graph, which is a qualitative methodology, which is a bit dangerous because it's very simple, that needs to be tailored to the specific need and needs to be approved. And that's what the current problem is, because, very few people know how to tailor, or very few national safety authority have accepted a specific way of tailoring it. So my suggestion is to stick with the classic methodology if possible, and then refine and adjust if nothing is available. The risk graph is one option, I will say. And in a few countries, the risk graph is the main option because this has been standardized by the National Safety Authority.
Great.
There are other methodologies that are available. Just happy to discuss. I don't think this is now the right forum.
Looking into the time,
Thank you.
Great insights, mate. Great insights. We will move to the next portion of the project. We spoke about reliability and safety with respect to RAMS. Now, how do RAMS standards contribute to overall life cycle costing, commercial considerations in railway projects, and what impact do they have on project sustainability?
Thank you for this question. This is a very, very sensible question because it's speaking about money and cost and sustainability of the project. Well, RAMS and LCC are very, very close together. LCC stands for life cycle cost, and it's the cost of project of a system starting from the beginning to the end. If you remove bid phase or just and typically what for the customer counts, it just in terms of LCC, it's just what is the cost of the system during the operation, and that is typically what a RAMS engineer need to answer to. So in the past, I had also a RAMS and LCC engineer. So, and my duty was to evaluate the cost of the system during the useful life, meaning once a product has been, so railway product, for example, a train has been handed over to the customer, what is the cost of this during the life, the 30 years, 40 years of life of the train? What is the cost in terms of quality maintenance, preventive maintenance, the skills one needs? And so the cost of labor skills, the people that one needs to have available, the tools, the special tools cost, the spare part cost. Most of the time, the logistic part, which was not foreseeable at the beginning, unless you have the precise location of the depots and all the stuff for the spare part, the logistic costs were removed. But just, those are typically part of the life cycle cost as well. So how a reliability engineer does that and how we optimize. Basically, when you do quality maintenance, preventive maintenance analysis, you attach because you know how long it takes to do that and what kind of sort of material you need. So you evaluate typical cost and also the labor cost. So you evaluate the cost for the system to just operate from the maintenance perspective, and you can add on top the energy cost, the special tool cost. So optimizing the maintenance schedule, the activities will reduce the cost and the impact of the project, also an impact on the sustainability of the project, reducing, for example, the resources consumption, the energy consumption. That is just greatly affecting the impact of the LCC. So for example, the choice of the material. Once I've been studying what kind of brake pads were good for a train, those that were more expensive but then were to be exchanged with a wider, or also on a schedule that was much wider, or just those that were a bit cheaper and just and then changed more frequently. So not always the cheaper option is the best option, I would say. So there are studies, engineers and LCC engineers that do this all the time. So, and also evaluate what is the best option for the operation of the system or the railway system.
Wow, it looks like a massive job. Amazing analysis and great insights in detail. Thank you very much, Daniela. You, as a STEM ambassador, and member of industry organizations, how do you contribute to promoting awareness and understanding of RAMS standards among professionals and the broader public?
Well, I do a lot of stuff and just to promote RAMS. RAMS is not well
Correct.
known and even if very important. And we have a lucky engineers globally, but mainly of RAMS engineer because this is what I care about. So as a STEM ambassador, I go to school to promote engineering and to the young kids and math basically, and just and try to get them to be passionate about engineering and the subject matter. Also, I explain what I do, try not to be boring, and to get the young generation to get closer to the engineering and to the RAMS engineering in there. I support standardization under BSI umbrella, so I'm supporting the British Standard Institution, and attend all the events and promote the RAM. Also, through the little knowledge I have, I try to bring my contribution to the standardization, trying to also make the standard more practical. That has been always my aim, and so my objectives in the beginning, because I'm a very practical person, and so I just try to see what is the advantage and how to put things in practice, basically. I do lectures to the universities. I'm writing scientific articles, and I try to support discussion in different forums, so within the company and also externally to the company, for example, in LinkedIn or other, I would say, social networks. Last but not least, I attend public events and give presentations where possible, where there are networking events, try to sensibilize the industry, mainly to receive RAMS and for best practice, because typically RAMS is seen as a burden and not as an advantage. I see it differently, and just use properly is giving a very, very big advantage, not only because of the perceptions of the customer, but because it just is optimizing the process and reducing the
I
costs.
do 100% agree with you. RAMS is really not very well known in the industry, especially in the railways. Thanks for promoting RAMS. Thanks for promoting the students to enter into the RAMS, especially in the rail industry. We need people like you, Daniela, and thank you very much for your insights, and thank you for your time coming onto this platform and sharing your knowledge on RAMS.
Thank you for inviting me.
I believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry. Contact me on railwaytransportationsystems@gmail.com. Thank you for your time today. See you next fortnight. Until then, stay safe and take care of yourself.